Alright, so in Chapter 2, Section 1, I want to look at a few problems. So here's our number 8. Write the quadratic function in standard form. So there's a specific form that's called standard form. In the book, they talk about the definition of a quadratic equation, and it's in this ax squared plus bx plus c form. That's what we typically see a quadratic put in. But it's when it's in standard form that we can find a little bit more, we can look at the function and see it a little bit differently. And so here's the standard form of a quadratic equation. That hk, that represents our vertex. The a represents, it tells us how narrow or wide the quadratic, the parabola is. Also tells us the direction that it goes. So when we have a function, a quadratic function that looks like this in standard form, we can tell a little bit more information about it. So on this particular problem, it's going to ask us to put this in standard form. So I'm going to have a supplemental video that will help us do that, a process called completing the square. Once we do that, the vertex we all know is that point high or low. The axis of symmetry is going to be that up and down line that it's symmetric to. And then our x-intercepts and y-intercepts. Now, just looking at a graph of this function, that would be easy to do. We could go to our Desmos and do that. Loading. Negative x squared minus 4x plus 2 was my function. And so I see it has a vertex. That's great. I see it has a y-intercept, 0, 2. It also has these x-intercepts. Those aren't exact values, right? So we're going to have to be able to solve this equation for 0. And I'll explain one of the ways if we're using the quadratic formula to do that. That would probably be the way that most people would do it to find these zeros. But we get an idea of what it's going to look like, which kind of also helps us if we're thinking about the standard form of a quadratic equation, right? It's in this form. H and K is my vertex. Well, I know what that is on here. So I know it's x minus, my h is my x term of my vertex, so negative 2. This is squared. And then plus k. And my k is my y value, so plus 6. So I almost have this, right? But then there's some a value in front. Notice, so it's a times x minus h squared plus k. So what I could do if I wanted to is I could just say, hey, let there be an a there, and I'm going to play around with it till I get it to match. Well, looking at the graph, if I go up bigger numbers, it's still going up. Once I go negative, I'm getting in that down direction, and I could probably figure out what it would be to match, and I think I have a match. I know that a is negative 1. So in standard form, I would have negative 1 x minus my h, so that would actually be plus 2 in this case, squared, plus 6 is the same thing as negative x squared minus 4x plus 2. So we've just kind of manipulated Desmos to help us figure out the standard form, which is kind of cool. But again, I'll show in a supplemental video how to do that and how to solve for those zeros. Let's also look at number 11. So number 11 says use a graph utility to graph the quadratic equation. No idea which one it is, but I know when x is 0, I could find a y-intercept real quick. When x is 0, that's 0 minus 30, I get negative 30. So it has to go through negative 30, so that kind of leads me to either this one or this one. But we could just graph that on Desmos or your calculator, and you could find out which one it is. And then it says find your x-intercepts. And again, that's setting it equal to 0. So on this one, we don't have to do a standard form. We just have to take this and set it equal to 0 to find where our zeros are at. Again, our zeros are, if it's this graph, would be where it crosses the x-axis. So to find those, minus 7x minus 30, we can see that this orange graph, it tells me which graph I'm looking at, right? So it looks like it was going to be B on our particular problem, this one over here, because this one was more to the left. And it also will, we can find our zeros. Like these are our solutions, graphically. We need to know how to do that algebraically as well, and so I will show us how to set this thing equal to 0 and solve it to get those answers of negative 2.5 or 6. Again, graphically or algebraically, we need to be able to solve this for 0 to get those values of negative 2.5 or 6. But that will be on an additional supplemental video. And lastly, number 12, find two quadratic functions, one that opens upward and one that opens downward, whose graph have the given x-intercepts. Well, when you're doing that, again, my points were 9, 0, and 8, 0. So I want them to have solutions that have a 9 in it and have an 8 in it. Would we all agree that this has a solution at 8 and 9? And it goes up. How could I make it not go up? Well, I could put a negative sign in front of it, and it's still going to have those solutions. So just understanding what a solution does, those points 8, 0, and 9, 0 being solutions, that just means it came from something that had a form of x minus 9 and x minus 8. So if we had a 0 of negative 2, that means I would have plus 2. So negative 2 and 9. If I wanted it to go up, I could just change the sign to a positive. And that would give me a parabola that is going up with those solutions. And so if you want to FOIL this out, that would give you the answers that they have here, probably. But again, there's infinitely many solutions, because all I would have to do is come back here and say 3 times that, still has that solutions. 0.5 that, still have those solutions. As long as it has that x minus 9, and I changed it, if I had a negative 2 solution, to x plus 2, like that product would give us a quadratic equation with those specific zeros. So I will follow up with a supplement to show how to solve this algebraically to find these zeros, and how to change this into standard form, and also solve for those zeros.